Hi everyone, so welcome back to my channel Mathematic Girl Swati 3226. So now I'm starting a playlist of NCRT, questions or NCRT explanations, I would say. So today I'm going to start with grade 8. So the first chapter, which is rational numbers. So I'll be explaining each and every line of NCRT book. So if any student finds the questions difficult or the concept difficult to understand, so this video is for all of those students. So you can watch this video till the end and you can understand the concept of rational numbers. So in this video, I'll be just covering the concept, not the questions of the exercise. For that, I'll be making another video. So in that you can, see the solutions of the exercise questions as well. So let's get started. I'm just going to share the entire screen so that you can see the PDF. Yeah. All right, so the topic that you can see is a rational number. So as I said, I'll be explaining you this one by one, line by line, each and everything so that you can understand the concept. So let's start with the first one, the first sentence. So the introduction part, in the introduction part we have given, in mathematics, we frequently come across simple equations to be solved. For example, this equation, as you can see here, which is x plus 2 equals 13, right? So in this x plus 2 equals 13, if you solve this equation, first of all, why is this called an equation? Because of course, in this, part, you can see that you are having an equal sign. So you are having one expression on the left-hand side, one on the right-hand side, separated by equal. So that is why it is called an equation, a very straightforward explanation. Next, now what is the solution of this equation? So clearly that what number will you add to 2 so that your answer will be 13? The answer is 11, right? Now clearly this is 11, which is a natural number. Now there is another concept that what is natural number? So natural number is nothing but the counting number that starts from 1 and it goes till infinity. So that is the answer for the natural number. So I'll go ahead. Okay, so meanwhile, I'm saying the definition of few of the, topics. Maybe you can write down the definitions as well. And I'll not be writing the definition because that will just make the video more long. So natural number, right? For example, the next one, x plus 5 equals 5. So in this x plus 5 equals 5, what will be the value of x so that, that number plus 5 will be 5, right? So of course, that should be 0, right? But what is 0? 0 is a whole number. Now there is another type of number. First, we understood about the natural number, which starts from 1 and goes till infinity. Now it's a whole number. So in just the set of natural number, if you add 0, it becomes a whole number, okay? Because in earlier time, there were counting numbers, people were using those numbers, but then they realized the importance of 0, that if we want to, denote something which is representing nothing, so for that, what kind of numbers we can use? So that is why we can use the whole number. Next, if we consider only natural numbers, equation 2 cannot be solved, of course, because here only 0 will satisfy this equation. And if you want to find out that the answer should be only from the natural number, you will not get an answer, right? So to solve equations like 2, we added the number 0 to the collection of natural numbers and obtained the whole numbers, the one that I said, right? Even whole numbers will not be sufficient to solve the equation like this. Do you realize that how exactly we are just going step by step? First, from this equation, we understood the concept of natural number. Then from this, we understood that why 0 is also important, right? Because some equations will not satisfy just with the natural numbers. So that is why we have the whole numbers. Next is x plus 18 equals 5. So in 18, what will you add so that the answer will be 5? So if you're not aware of this, there is a concept of negative numbers, right? So that is why there is one way to solve these equations, but I'll not be explaining you those ways right now because I'm explaining this topic by keeping in mind that you are from grade 8 and you are watching this video. So x plus 18 equals 5. That means in 18, what will you add so that the answer will be 5? So you can use the concept of the number line. The answer will be minus 13, which is neither a whole number nor a natural number, but it is a negative number. Okay, I'll explain you this in detail, that how exactly we are getting minus 13. And then maybe I'll explain you the method also, how to solve the equations. Okay, the answer will be here minus 13, which is a negative number. And from the negative number, we have another type of number, which is called integers. So what are integers? On the number line, as you know, There are numbers after 0 and there are numbers before 0 also, right? So the numbers after 0 are called positive numbers and the number before 0, they are called negative numbers. And 0 is a special number. It does not come in the category of positive or negative. It has its own name and that is called neutral number. Why 0 is called a neutral number? Because 0 has no sign. You will never see that we write on 0 as plus 0 or minus 0. That is wrong. We always write on 0 as just 0 because it is signless. All right, so we have understood three types of numbers starting from natural numbers, whole numbers, and integers. When we combine the positive, negative, and the 0 together, they are called integers. Now, there is a note that is given. So, as I said, I'll be explaining each and every line. So, let's go ahead. Note that the positive integers correspond to natural numbers. Of course, when I'm saying what are positive numbers, I'm saying all the numbers on the right side of 0, right? So, what are the numbers on the right side of 0? 1, 2, 3, 4, 5, 6, 7, 8, and so on. But they are also called natural numbers. So, if you notice, natural numbers are actually two more names, are having two more names, and that is counting numbers and the positive numbers as well. One may think that we have enough numbers to solve all the simple equations with the available list of integers. That means we can use natural numbers, whole numbers, and now integers as well to solve any kind of equations. But there is another equation like this. 2x equals 3. What is the meaning of 2x here? That 2 is getting multiplied with x equals 3. The question is that what will you multiply with 2 so that your answer would be 3? Okay, you will be amazed that, of course, in 2's table, 3 does not come. So how can we get the answer? The answer will be a different type of number, which is 3 by 2. So if in 2, if you multiply 3 by 2, the answer will be 3. Do you know how? Because this 2 and 2 will get cancelled because that is 1. So 1 into 3 is 3. So what is the value of x? 3 by 2. Now, will you say 3 by 2 is a natural number? No. Will you say 3 by 2 is a whole number? No. Will you say 3 by 2 is an integer? No. Because it is not satisfying the definitions of all these three types of numbers. That is why now we have another type of number which we call as a rational number. Okay. Now, what is rational number? The definition must be given here, but I'll tell you here, which you can write down also. That rational numbers are those numbers that can be written in the form of P by Q. I'm using a letter P by Q. You can use A by B, R by N, any alphabet you want. So a rational number can be written in the form of P by Q, where the conditions for P and Q are given, right? The condition for P and Q are that P and Q both should be integers, both can be integers, whereas Q can never be equal to 0. 0 is an integer? Yes, 0 is an integer. So that is what I'm saying, that P by Q, we can write down rational numbers in the form of P by Q, where P and Q are integers. So Q can be 0 also, but that is an exception. What's an exception? That we can never write down 5 by 0, 6 by 0, 7 by 0 this form, because the answer for these types of numbers will be undefined. Okay. So you can notice one thing here, that in denominator, now another word I used, denominator, right? So there is another concept which is fraction. So in fraction, we write down a top number and we write down the bottom numbers. The top number is called numerator and the bottom number is called denominator. Denominator can never be equal to 0. Okay, because if it is 0, it will be undefined. Okay, I hope you understood this concept. Let's read the next one. So now consider the equations this and this. You will not get an answer from the set of natural numbers, whole numbers, and integers. That is why we have the numbers of the type 3 by 2 to solve this equation and minus 7 by 5. Now, how did you get minus 7 by 5? I'll explain you this later on. To solve equation, this leads us to the collection of rational numbers. So if you want, you can also represent, these numbers using small circles. The smaller circle is the natural number. Bigger than that is a whole number. Even bigger than that is an integer, which we represent by using the letter Z or Z. You must be wondering why? That why not I? It's just, that they have just mathematicians or the, like earlier time people were using Z for some reason. Z. And then after that, we are having the concept of bigger than integers, rational numbers. Now again, rational numbers we do not represent by R, but by Q, because R is already assigned for another type of number, which maybe you will see it in this class or maybe in class 8th. So we have already seen these basic operations on rational numbers. We now try to explore some properties. Now, properties are very interesting. So let me tell you, if you're already aware of these properties, the properties are closure property, commutative property, associative property, distributive property, and identity property. Now let us see that how many properties are mentioned here in this topic. Just a moment. I'm just hoping that the screen was visible in the entire moment. Yeah. So the next we have the properties of rational numbers. Yeah. Yes. So the first one is closure property. What does the closure property say? Okay. The closure property simply says that if you're taking a number, let's say that you're taking a whole number, okay, and you're taking another whole number, the answer is also a whole number. If that condition is being satisfied, that is called the closure property. That means you're taking one number from one type of number and another number from another type of number, right? And the answer is also from the same category, that is called closure property. So let us first check for the whole numbers, whether the closure property satisfies in every cases or not. Yeah. So let us revise the closure property for all the operations on whole numbers in brief. So what are the operations? I hope you know that there are 4 operators: addition, multiplication, subtraction, and division. So for addition, okay, you can see the numbers are taken as 0 and 5. Is 0 a whole number? Yes. Is 5 a whole number? Yes. So we took 2 whole numbers, we added them, and we got an answer 5, which is also a whole number. So the whole numbers are closed under addition. Why? Because you took one number, another number, and the answer is also from the same category. Right? Now if you want to prove something wrong, you should give one counter example. For example, I'm saying that this is correct, and you think that no, this is not correct, then you give me one example where it will not be satisfied, then you are done. But you'll not be able to give any counter example in this case. That is why whole numbers are closed under addition. Next, 4 plus 7. Is 4 a whole number? Yes. Is 7 a whole number? Yes. Is an answer a whole number? Yes. So in general, a plus b is a whole number for any two whole numbers a and b. That is why the whole numbers are closed under addition. Now let's check for the subtraction. So for the subtraction, as you can notice here, that if I take a whole number, let's say 5, if I take another whole number, let's say 7, and if I subtract them, the answer is not a whole number. You know that whole number starts from 0, 1, 2, 3, and so on till infinity. But negative numbers do not come under whole number. Here you took a whole number, you took another whole number, you subtracted it, and you did not get a whole number. So that is why it is not closed under subtraction. Now you may ask that if I take 10, which is a whole number, if I take 5, which is also a whole number, and 10 minus 5 is 5, which is a whole number, so why not it is true? Yes, it is true. But I am able to give one counter example here, that there is one example where it is not coming true, which we could not give in the case of addition. That is why whole numbers are not closed under subtraction. Okay, I hope that is clear. Now let's go to multiplication. So multiplication is also very simple like addition. But if you take a whole number, another whole number, then it is 0, right? So the answer is coming a whole number only. Whole number, the answer is also a whole number. So whole numbers are closed under multiplication. So 3 is a whole number, yes. 7 is a whole number, yes. 21 is a whole number, yes. It is satisfying the property. So in general, we can say if A and B are any two whole numbers, their product AB is also a whole number. Okay. So that's it. Next, division. Division is like a subtraction. So you can notice here one thing, that addition and multiplication like a similar property, and then the subtraction and division not getting satisfied. So in division, you can see that if you take a whole number 5, if you take another whole number 8, is your answer a whole number? No, it's a rational number, right? That is why it is not closed. Now again, your question can be that if I take 10, if I take 5, I am getting a whole number. Yes, you are, but you are able to give a counter example, and there are so many examples like this, so many counter examples like this where it will not be true. So that is why whole numbers are not closed under division. So overall, we can say, if I just combine all of them together, that for whole numbers, closure property is satisfied only for addition and multiplication, but not for subtraction and not for division. That's it. Now let us check for integers. Okay. Oh, okay. Something happened. I think I have started the slide. Sure. No worries. That's okay. But I think that will be difficult. So I'll do one thing. I will just close the slideshow and then start. Okay, so there. No need to do the slideshow. That is much more comfortable. Okay, so I think you can see my shared screen again. Yeah, so we were talking about whole numbers, right? Whole numbers completed. Now we are checking the closure property for integers, right? So integers under addition. First, you can see the answer that it is closed, right? So if you take any integer, -6 is an integer, yes. 5 is an integer, yes. The answer is an integer, yes, because negative, positive, they are integers. So it is satisfying. Same, -7 plus -5. If you're having any doubt in solving this, -7 plus -5, let me tell you here that this will become -7. Plus into minus is minus. There is a rule, right? Plus into minus is minus. If you're having doubts in these things, do let me know in the comment the comment section. It's like I have a habit of saying the chat box because of the classes that I take. So I was just about to say the chat box. Anyway, so you can comment down that if you have any doubt in these things, like how to multiply the signs, then let me know. I'll make a separate video for that. So here plus into minus will be minus, and then 5, which is -12. So of course, -7 is an integer, yes. 5 is an integer, yes. They are getting added, okay? It was getting added only. I just simplified it. And the answer is also an integer, so that is why, yes. So in general, if a plus b is an integer for any two integers a and b, it will satisfy the closure property. Now let's check for subtraction now. That's surprising that it will be true for subtraction as well. You take one integer, you take another integer, you subtract it, you will get an integer. You take another integer, 5 minus 7, the answer is -2, which is also an integer. So integers are close under subtraction too, which was not in the case of whole numbers. Let me tell you one thing that for whole numbers, whatever were the conditions that we checked, say similar answers will be for the natural numbers as well with the same reason. Okay. So even if it is mentioned here, I'll just read it out and maybe you can understand it on your own. So for subtraction also it is true. Let's go to multiplication now. Oh, we have more. Let us understand this as well. So -6 minus -6. So let me tell you that this is your integer, which is -6, and this is your integer, which is -8. Are they getting subtracted? Yes. The answer has come 2, which is also an integer. So that is what is being satisfied. Now the question is that how do we solve this? Okay. So to solve this, we just write down -6. Minus into minus becomes plus, which is 2. That's how we got 2. Again, if you have any doubt in this, do let me know in the comment section. If you are a student, not just from 8th grade, but from any grade. And if you want to understand this, if you have any doubt, let me know. Next, is 8 minus -6 is an integer? Yes. 8 is an integer? Yes. -6 is an integer? Yes. They're getting subtracted? Yes. The answer will be an integer? Yes. How? Because minus minus will become plus. 8 plus 6 is 14 and 14 is an integer. So it is satisfying the closure property. So in general, for any two integers, we can say a and b. For a and b, a minus b is again an integer. And you can also check for b minus a. That will also be an integer. Okay. So for integers, the closure property is satisfying for both addition and subtraction. Now let's check for multiplication. For multiplication also it will satisfy. 5, 8 integer, answer integer, satisfied. -5 is an integer, 8 is an integer, the answer is -40. Satisfying. It is also an integer. -5 is an integer, -8 is an integer, the answer is 40. Why 40? Because minus into minus is plus. That is also an integer, so it is satisfying the closure property. In general, for any two integers, we can say a times b will also be an integer. If you're having any doubt in these statements, like what is in general and all, so it's like we are just generalizing it, that if it is like true for a few numbers, then for any numbers, and for those any numbers, we are using the like the alphabets a and b, because we are just not saying that for this and this number only it is true, but for any number. Okay. All right. Next, division. Of course, for division, it will not be true, because if I take an integer, if I take another integer, my answer will not be an integer because 5 divided by 8 will be something in decimal, right? If you are aware of the decimal numbers, which is of course a rational number, not an integer. So that is why integers are not closed under division. What you can do is you can make a proper chart where you can write on all the properties name, all the operations, and you can just tick. It is satisfying, yes. It is not satisfying, no. Satisfying, yes. Not satisfying, no. Like that. Okay, so that would be a nice practice of yours. Now it's time to read the. So see, you can see that natural numbers they have not given because it is exactly same as the whole numbers. Okay. Now you have seen that the whole numbers are closed under addition and multiplication, but not under subtraction and division. However, integers are closed under addition, subtraction, and multiplication, but not under division. Okay, so I hope you understood this. Now let us talk about rational numbers. Now they have given the definition of a rational number, which I have already said, that a number which can be written in the form of P by Q. I think I'll be using a highlighted smart pen. Okay, what is smart pen? Oh, okay. So I think it's just getting converted into the shape. So a number which can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. The main part, right? That the denominator can never be equal to 0. They are called rational numbers. For example, minus 2 by 3 is a rational number. Yes. Minus 2 is an integer, 3 is an integer, and Q is not equal to 0. 6 by 7, 9 by minus 5. In fact, 0 is also a rational number. Why? Because 0 can be written as 0 by 1, 0 by 5, 0 by 7. Still, it will be 0 only. But is it written in the form of P by Q? Yes. Is 0 an integer? Yes. Is 1 an integer? Yes. Is Q not equal to 0? Yes. It is satisfying all the conditions. So that is why they are rational numbers. Since the numbers 0, minus 2, 4 can also be written in the form of P by Q, therefore they are also called rational numbers. Check it. We checked it. And that's the answer. Okay, now we have to check whether it will be satisfying the closure property or not. So let me tell you that if you take two rational numbers, the answer will be rational numbers, so it will be satisfying. If you take two rational numbers and if you subtract them, it will be still a rational number, so it will satisfy. If you take two rational numbers and if you multiply, it will still be a rational number. And if you take one rational number, another rational number, and if you divide, you will still get a rational number with one exception, that is 0. Okay, so I'll explain you that. I'll just read the lines. So here it says, you know how to add two rational numbers. That's another concept now. That how do we add the fractions? So yeah, rational numbers, this and this, if you add, this is the answer. If you're having any doubt again here that how it is getting added, let me tell you that this is a concept of fraction. If I go here, then I'll not be able to finish it. Okay, so that is I'm not going here. If you're having any doubt, you let me know. I'll make a separate video for that. So if you add two rational numbers, you'll get a rational number. If you add, like there are some more examples, right? And now we find that this is the generalized statement. The sum of the two rational numbers is again a rational number. Check it for a few more pairs of rational numbers and you will see that you'll get the same answer. We say that rational numbers are closed under addition, the main important line, right? We can say that rational numbers are closed under addition. That is for any two rational numbers, a and b, a plus b is also a rational number. That's it. All right, now we can go to the next one. The subtraction, as I said already, that if you subtract, you will still get a rational number. So will the difference of the two rational numbers be again a rational number? The answer is yes, as you can see here. So if you subtract 5 by 8 minus 4 by 5, you will get the answer as minus 7 by 40, which is of course a rational number. If you subtract this, you will still get a rational number, which is the case of the closure property. So try this for some more pair of rational numbers and you can see that the rational numbers are closed under subtraction. That is, for any two rational numbers a and b, a minus b is also a rational number. Now let us go to the multiplication, which again I have already explained, but let's just read it. So let us now see the product of two rational numbers. You are having two rational numbers. When you do the product, you get both the products to be rational number. Is this a rational number? Of course, it will be a rational number. Remember how to multiply the rational numbers. Multiply the numerator with the numerator and denominator with the denominator, and you have to take care of the sign as well. For example, here minus 4 into minus 6, it will become 24 because minus is plus. And 5 into 11 is 55, which is a rational number? Yes. So take some more pairs of rational numbers and check that the product is again a rational number. You will not be able to give any counter example. So we say that rational numbers are closed under multiplication. That is, for any two rational numbers A and B, A into B will also be a rational number. All right, now it's a case of division. You take any rational number, right? You can see that here we have taken a rational number, the answer will also be a rational number. So that means it is satisfying. So we can say that for integers, for rational numbers under division, it will be true. But with an exception. What is an exception? The exception is that we find that for any rational number a divided by 0, right? So by 0, that is wrong. Because you know, there is a definition of p by q where q, it is just taking the shape. Q should not be equal to 0. So that is why we cannot write down the denominator as 0. That is an exception. Otherwise, it is satisfying. So it is written here. However, if we exclude 0, then the collection of all the rational numbers is closed under division. So you can say yes, except 0. All right, so now it says try these. So fill in the blanks. For rational numbers, addition, yes. For, I think it was already done. Oh no, there are some blanks. For subtraction, yes. For multiplication, yes. For division, it is written no. But you can say that it is actually yes with an exception 0. Okay. So because they are not considering maybe the exception, so that is why they have written 0. For integers, addition, yes. For subtraction, yes. For multiplication, it will be of course yes. And for division, it is no. For whole numbers, we of course noticed that it was yes. For subtraction, it was a big no. For multiplication, it was yes. And for division, no. And natural numbers, it was not mentioned, but I already explained it. It is the same as the whole number. So yes, no. For multiplication, yes. And for division, no. So that's the answer. All right, let's go to the next part. Commutative property. See, we are done with the closure property now. Closure property, you understood that we are taking one number from one category, another number from another category, and we are using different operators. And are we getting the same category or not? That was closure property. Now it's a commutative property. So I'll just tell you in short that what is the meaning of commutative property. So commutative meaning if you swap the numbers, are you getting the same answer or not? For example, 2 plus 3, 5. But if you do 3 plus 2, the answer is 5. This is called commutative property. If you do 2 times 3, 6. If you do 3 times 2, the 6. Are they same? Yes, close. Commutative property. That is called commutative property. Now let us check that for addition, subtraction, multiplication, division, are they true or not? For addition, okay, recall the commutativity of different operations for whole numbers by filling the following tables. For addition, 0 plus 7 will be same as 7 plus 0. Yes, addition is commutative. 2 plus 3 will be same as 3 plus 2, which is 5, commutative. So for any two whole numbers, A and B, A plus B will be equal to B plus A. For subtraction, it is already written not commutative, and I can clearly say why. What is 3 minus 2? I think I have to change this smart pen. So what is 3 minus 2? It is 1. But if I ask you what is 2 minus 3? Is it 1? No, it's minus 1. So is 3 minus 2 same as 2 minus 3? No. That is why it is not commutative. Next is multiplication. Is commutative. Why? Because if you do 2 times 5, will it be same as 5 times 2? Yes, it will be same. So commutative. Division, it will not be true. For example, if you do 10 divided by 2, the answer is, see, what is 10 divided by 2? The answer is 5. But if I do 2 divided by 10, the answer will be 5. No, it will be 1 by 5, which is not same as 5. So that is why this is not equal to, and that is why division is not commutative. So for addition, for whole numbers, addition is commutative, multiplication is commutative, but subtraction and division, they are not commutative. All right, let's go to the next part. So now for integers, we are checking, right? So for integers, it is written addition is commutative. Yes, it will be commutative. For subtraction, it is not commutative because you can clearly see that if you take 5 and minus 3, and if you subtract it, you will get the answer as 8. But if you write on minus 3 first, and then subtraction symbol, and then 5, are you getting 8? No, you're getting minus 8. Is 8 equal to minus 8? No. That is why it is not commutative. So it is not commutative. Next, multiplication, it is commutative. You take any integer, let's say minus 2 into 3, the answer is minus 6. If you take 3 into minus 2, the answer is still minus 6, which are same, so commutative. Division is not commutative, same reason, okay? It will not be commutative. Let's go to the rational numbers. So for rational numbers, Of course, it will be commutative. If you add this way or that way, it will be the same answer. So it will be commutative. Okay, I'll just read it. So you know how to add two rational numbers. So they are expecting that you already know how to add the rational numbers. Or I can also use here the concept of fraction. Okay, so it's a concept of like and unlike fractions. If you're aware of it, well done. If you're not, as I said, let me know in the comment section. So if you add this, you are getting here 1 by 21, as you can notice. And if you swapped it, so 5 by 7 first and then 2 by 3, then also you're getting the same answer. So that is why it is commutative. So if you take more examples, you will say it, like you will see that it will be commutative only. Now let us go to the next. So I'll just write down this here. So they're saying that is this also the same answer? You check this if you know how to solve it and find out the answer. So you find that the two rational numbers can be added in any order, right? This way or the other way. So we say that addition is commutative for rational numbers. That is for any two rational numbers, a and b, a plus b will be same as b plus a. So for integers, rational number is commutative. Okay. Subtraction. Will it be commutative? Of course not. Just like 3 minus 5 is not same as 5 minus 3. Even if you take a fraction, it will not be the same. So subtraction is not commutative for rational numbers. Note that subtraction is not commutative for integers and the rational number also. So yeah, just remember this, that subtraction is like very rare. It will not be true in most of the cases. I hope that is clear. Multiplication, of course, it will be commutative. You multiply in this way or the other way around, you'll get the same answer, be it integers, rational numbers, whole numbers, natural numbers. For division, it will not be commutative, as you know. If you take one rational number divided by the other one, you'll get one answer. But if you swap it, it will not be the same answer anymore. That is why it is not commutative. So as you can see, that here we have the question given for rational number addition, yes. Subtraction, will it be commutative? Will you get the same answer? No. For multiplication, yes. For division, no. For integers, commutative property, yes. Subtraction, no. Multiplication, yes. Division, a big no. Whole numbers, addition commutative, of course, yes. Subtraction commutative, no. Multiplication, yes. Division. For natural numbers, commutative, yes. Subtraction, no. Multiplication, yes. And that is no. So remember that for commutative property, it's not like a big deal to remember this. For just addition and multiplication, it is true. But for subtraction and division, it is not true. And that's the answer. Okay. So let's go to the next one. So now we have the associative property, and I think that the video will be very, very long. So maybe I'll be making another part for this. And that is it for today. I hope you understood everything, and don't worry, I'll be making videos for the higher grades as well, for class 9, 10th, maybe 7th, 6th as well, for 11th, 12th too. I thought that I'll be covering some of the chapters from the, from the grade group 7 to 10. So that is what I have started. I hope you will understand each and everything. So thank you so much for watching the video till the end, and I'll see you in the